Hi everyone, my name is Kartik and my channel is about mental models. Recently in my multiplying by zero mental model video, I mentioned the systems thinking mental model, and this is what I will be introducing in today's video. On the multiplying by zero mental model video, I also drew the following connection, like this. Showing essentially the connections to the systems thinking mental model, the connections between the multiplying by zero, multiplicative systems, additive systems to the systems thinking mental model. I just wanted to put that out there because I will come back to this diagram, these connections a little bit later. When I presented the multiplying by zero mental model video, I was thinking of doing a single video on systems thinking, but when I started to plan this video, I thought rather than cramming everything into one long video where you may potentially lose interest, I thought it would be better to present this as another mini-series. So welcome to the first video of another mini-series, this time on systems thinking, which will be 9 videos long. 1 of 9. The reason of presenting this as a mini-series, apart from cramming everything into one video, is that systems thinking isn't a single mental model. It is a collection of models which together can give you a new perspective on problem solving and decision making. So firstly, what is a system? Well, to answer that, let's take a step back and answer the question, why do we even care about systems? Well, I've just said that this systems thinking mental model approach can give a new perspective on problem solving and decision making, and ultimately the goal is to be able to make the correct decision in order to solve the problem. But in order to solve the problem, we need to first understand the problem. And as problems exist within systems, in order to understand the problem, we need to understand the system. So why do we care about systems? In order to understand the problem effectively. Otherwise, what will happen is, or what is more likely to happen, is that we will remedy the symptoms of the problem that we're trying to solve, rather than solving the problem itself. So we need to understand the problem in order to effectively solve the problem. And in order to do that, we need to understand the system, and that is why we should care about systems. And so going back to the question of what is a system, now that we know why we should care about it, when I say the word system, one may think of something like a, let's say, a computer system. Or maybe even an alarm system. And these are good examples of systems, but what about the economy? What about marriage? What about the human body? Well, all of these are systems too. And taking the human body example a little further, within the human body there are further systems such as the nervous system, the immune system, and even the digestive system. So the point I'm making here is that we can have systems within systems. So they can be within one another. So to answer the question of what is a system, it's not that it's simply a collection of parts, but rather a group of interconnected and interdependent parts that work together towards a specific purpose. So, in other words, it's not a collection of parts, it's a group of interconnected and interdependent parts that work towards a specific purpose. Now, I've given some examples of what a system looks like, or what systems look like. But these are quite specific, so if we sort of take a step back and look at this sort of more generally, what does a system look like? Well, it has, draw it up here, it has a boundary, and that boundary separates the system from its environment, and then it has inputs and outputs. So that's what it looks like in a very simplistic sense. But what else is there apart from that? Well, to add to this, as I've said, it's got a purpose. The other thing, or the other elements, are that all parts must be present. So within this system here, all parts must be present, and this is known as the irreducibility of the system. And also, another characteristic of a system is that they may only be arranged in a specific order. So what do these two things mean? Well, if pieces can be taken away, so I'm just looking at this point here, all parts must be present. If pieces from within the so-called system can be taken away without it affecting its functioning, then you have a collection of parts. So let's say you have a drawer full of clothes. If you take some clothes out to wear, then you haven't changed the nature of the drawer. So you've taken some parts out of the system, but it doesn't actually, or it hasn't actually affected the nature of the drawer. And so in that case, because you haven't changed the nature of what the drawer is without all the parts being present, it's not a system. Similarly, if you change the order of the clothes in the drawer, so going on to the second one, arranged in a specific order, if we change the order of the clothes, put the clothes that were on the top on the bottom and just shuffle them around, then again, we haven't changed the nature of the drawer and we haven't affected its functioning. So in these cases, what we have is a collection of parts, not a group of interconnected and interdependent parts working towards a specific purpose, where all parts must be present and arranged in a specific order. So we do not have a system, simply put. So without these two things, specifically, without these two things, in practice, the system will either not function or the performance of the system will be severely impacted. So the other stuff is quite important too, but in practice, if we start taking parts out of the system or we arrange them in a different way, let's say a car engine, if we start taking parts out of a car engine or we arrange the engine in a different way, it might not work or it will work very badly. That's what I'm trying to say. That's what defines a system, as well as the other the other points above it as well. And all systems, so one more thing, all systems have some form of feedback. Now, feedback is the transmission and return of information which helps the system to maintain its stability and not collapse on itself or explode. Finally, I want to end this video where I started by reiterating that systems thinking isn't a single mental model. It's a collection of models. So as I said, I'll come back to this connections diagram a little later. Going back to this drawing now, if I expand this out, so this is my systems thinking box, if I just expand it out here, this box, actually, I'm going to try and see if this works. This box, which is systems thinking, can be expanded into the collection of mental models, which will look a little bit like this. And so there are 7 mental models, and they are all connected with each other. Like so. And then you have that one connected here, one connected there, this one connected here. And each of these circles with a number inside of them, each of these represents a mental model in itself, which is what I will be covering in the course of this mini-series, and then a final further video to bring everything together. So these 7 models are, so I'm just going to sort of list them out here. Number 1 is pathways. Number 2 is stock and flow. Number 3 is the Iceberg model. Number 4 is pinch points. Number 5 is solutions. Number 6 is feedback or feedbacks. And number 7 is equilibrium. So these are the 7 which are represented in this diagram over here. So just to sort of explain that again, I've got one box which is systems thinking, which is representing the mental model, but actually systems thinking is a collection of mental models. So I've expanded that out to show the collection, which has 7 mental models within it, and those 7 are connected in this fashion. And those 7 mental models that make up systems thinking are pathways, stock and flow, Iceberg model, pinch points, solutions, feedbacks, and equilibrium. So that's all for this video. It was just an introduction into systems thinking, and we will dive into each of these mental models in the coming videos. Thank you for watching, and thank you all for your continued support on this channel. As always, please like and subscribe and share with your friends. And I will see you again in the next one. Thank you. Bye-bye.